What if I told you that Lady Gaga is currently shaving, a whole year off the biological timeline for pharmaceutical testing by using artificial intelligence on living 3D printed human skin?
Wait, Lady Gaga.
Lady Gaga, welcome to episode 608 of AI Brief. So today's deep dive is centered on a really fascinating shift happening right now. We are looking at how rapidly artificial intelligence progress is becoming highly expensive, deeply investable, and, well, surprisingly physical.
Oh, definitely.
We are watching the technology move from the abstract cloud directly into our everyday work and, quite literally, into our biological reality. We have a massive lineup to get through.
We really do.
We will be looking at Lady Gaga's new AI skincare startup, analyzing some staggering hardware price hikes coming from Nvidia, and unpacking Anthropic's quiet but powerful moves in the enterprise sector.
Taku.
We will also touch on Dr. Drea's completely unfiltered take on AI in the music industry, and finish up with a practical breakdown of today's trending productivity tools.
The sheer scale of the developments happening right now is genuinely staggering, when you step back to look at the whole picture. We are sitting at a point where this technology is simultaneously solving microscopic biological mysteries inside sterile laboratories, while at the same time driving multi-billion-dollar corporate valuations on Wall Street.
It's wild.
It is a complete vertical integration into every single layer of reality and commerce.
That intersection of biology and computing is exactly where we're starting today. Let's look at artificial intelligence stepping out of the software realm and into the physical world, specifically the biotech space.
Okay, let's get into it.
The big news here is the emergence of a company called Outer Bio, which was co-founded by Lady Gaga and Michael Polanski. They have just come out of stealth mode with a platform called Una.
Okay.
And what Una does is fundamentally change the timeline of biological testing. It uses a 3D printed scaffold to keep human skin, specifically full-thickness ex vivo skin, alive for 4 weeks.
Full-thickness ex vivo skin,
Meaning living tissue that has been removed from a body. It keeps it alive by constantly feeding the tissue nutrients and clearing away cellular waste through these microscopic channels.
Oh, wow. 4 weeks is a long time for tissue to survive outside a body.
It is. Now, to understand why this matters, you have to realize that normally human skin kept in a lab environment only survives for about a week before it breaks down.
So they've quadrupled the lifespan.
Basically. Think about traditional lab skin testing like watching a 10-second movie trailer. You see a few quick flashes of action, maybe you apply a chemical and see some immediate irritation or a quick burst of hydration, but you have absolutely no idea how the plot actually resolves.
You miss the whole ending.
You completely miss the long-term cellular turnover. The Una platform essentially lets the AI grab some popcorn and watch the entire feature film to observe the long-term effects of these compounds.
That makes total sense.
Data from those month-long experiments feeds directly back into an AI system. The AI analyzes how the cells reacted over time and then proposes new active skincare compounds that are mathematically likely to affect a specific skin process.
So it's a closed feedback loop.
A complete loop. Every single result, whether it is a success or a failure, sharpens the next prediction. By doing this, Outer Bio cut their discovery time from finding 2 leads in roughly 18 months down to generating a new candidate every 6 weeks.
That is a massive acceleration.
They already have 6 active leads currently in the pipeline.
Well, the scientific backing for this methodology is incredibly solid, which is what makes it more than just a celebrity vanity project, There's a bioRxiv preprint detailing exactly how the Una platform successfully reproduced known dermatological results.
Oh, they published their testing methods.
They did. For instance, researchers were able to artificially induce a psoriasis-like state in the living tissue. They then successfully reversed that severe inflammation using a JAK inhibitor.
JAK inhibitor.
For those not spending their weekends in a biotech lab, a JAK inhibitor is essentially a specialized enzyme blocker that shuts down the body's internal inflammation pathways. They also demonstrated severe UVB radiation damage on the tissue and showed how it could be physically eased and protected by applying sunscreen.
So they proved the skin acts like normal skin.
Precisely. Proving that the platform behaves normally under known conditions validates the entire AI discovery loop. If it reacts predictably to known threats, we can trust how it reacts to novel compounds.
That is fascinating.
However, we do have to consider the biological limitation here.
There is always a catch.
There is. This is still a partial version of human skin. Because it is isolated on a 3D scaffold, It completely lacks a vascular system,
So no blood vessels.
no active blood flow. More importantly, it lacks the complex immune cells that human skin would normally recruit from the rest of the body when responding to an irritant or a pathogen.
Oh, because it's cut off from the host's immune system.
Exactly. I mean, spot on. It is a massive leap forward for testing active compounds quickly, but it is not a perfect one-to-one simulation of a whole human biological response.
I see. Well, running a continuous data-heavy platform like Una, constantly processing complex biological reactions and training predictive models, that requires immense computing infrastructure.
Oh, absolutely massive amounts of compute.
All that processing power does not just materialize out of thin air. That reality perfectly segues into the broader market movements we are seeing today because the hardware and software layers powering all this biological discovery are shifting dramatically. I'll let you break down exactly what is happening with the infrastructure.
Sure. So the industry landscape is undergoing some massive financial and structural adjustments right now, starting at the very bottom with the hardware foundation. Nvidia is reportedly planning to raise prices by more than 15% on server shipping in 2027.
15%. That is a huge jump.
It really is. According to market reports, this significant price hike will directly impact their highly anticipated Vera Rubin and Grace Blackwell systems.
The next generation chips.
Yes, the underlying cause for this increase is the ongoing severe memory chip shortage. Nvidia is essentially in the same boat as Amazon and Apple, both of which have also been forced to hike their prices this year due to these identical supply chain bottlenecks.
So the physical materials are the bottleneck.
When the physical components that store the data become scarce, well, the cost to build the brain goes up for everyone.
That 15% hike on enterprise-grade servers is going to translate to billions of dollars in added costs for the companies training these models. But Nvidia isn't just sitting back and selling hardware, are they?
Not at all. Beyond hardware pricing, Nvidia is aggressively expanding its model development capabilities. They just struck a massive $6 billion deal to license technology from Poolside.
$6 billion. This agreement pulls more than 100 engineers directly onto Nvidia's Nematron team. They are heavily focusing their efforts on building powerful, open-weight models.
And open-weight models, as a reminder for anyone who missed it, are systems where the underlying architecture and parameters are available for developers to download, modify, and run on their own hardware.
As opposed to being locked behind a corporate API.
Got it.
Looking at the broader ecosystem that supports those models, Hugging Face is currently exploring a sale that could value the company at $13 billion or more.
Wow, $13 billion.
To put that staggering number in perspective, their valuation in 2023 was just $4.5 billion.
That is a massive jump in just a few years.
It really highlights the demand. This jump is backed by their massive repository, which operates essentially as the app store for machine learning. It now hosts over 2 million models and 1.5 million datasets.
That is an incredible amount of data. Then we have Anthropic making aggressive dual moves in both the enterprise and financial spaces. Technologically, they have rolled out Claude Mythos 5, which is now the engine powering Claude security for enterprise clients.
Claude security.
This is a fascinating use case. It allows major companies to point a highly sophisticated cybersecurity savvy model directly at their own internal code bases to scan for vulnerabilities and automatically generate suggested fixes.
That sounds incredibly useful, but also slightly terrifying if it makes a mistake.
Which is exactly why they're moving beyond their initial Project Glasswing partnership program to offer this more broadly. But the rollout is deliberately slow. They are throttling access specifically for safety reasons.
Makes sense.
They want to ensure the model doesn't hallucinate a fix that actually opens a new backdoor in a corporate server.
That would be a disaster.
Simultaneously, on the financial side, bankers are telling investors that Anthropic could raise over $100 billion at a staggering $2 trillion IPO valuation.
$2 trillion. Wait, $2 trillion?
We are talking about pricing a software company, like a medium-sized nation-state.
That is just... It's hard to even wrap your head around that number.
Finally, in the sector-specific application layer, the legal artificial intelligence startup Harvey has just released a new model called Tenet.
Okay, Tenet.
This is their first post-trained model built specifically for long-horizon legal work. It is highly optimized for token efficiency.
In the AI world, a token is basically a chunk of a word.
So when you are processing a massive multi-hundred-page corporate merger document, you are dealing with hundreds of thousands of tokens. If your model isn't efficient, it either forgets the beginning of the document by the time it reaches the end, or it costs an absolute fortune in computing power to process.
I see.
What is particularly notable here is the foundation they chose for this highly efficient system.
Hmm.
Tenet was built on top of Moonshot AIA's Kimi K3.
I have to jump in on that specific point about Harvey and Kimi K3, because the irony there is impossible to ignore. Harvey is arguably one of the most prominent legal AI startups in the entire world, and they have been heavily backed by OpenAI since 2022.
OpenAI is their marquee investor.
They are. Yet when it comes time to build their flagship long horizon model, the tool they are staking their reputation on for complex legal work, they chose an external open weight model as their foundation, rather than exclusively using OpenAI's proprietary technology.
It is a surprising move.
It clearly signals a massive industry preference for the control, privacy, and fine-tuning flexibility that open weight models provide, even when you have direct financial ties to closed model giants.
It is completely ironic. You would naturally assume an OpenAI-backed darling would stay in the family, but it just proves that when you're dealing with highly sensitive, massive legal documents, the flexibility of tweaking an open-weight model yourself completely trumps brand loyalty.
Money talks, but efficiency wins.
To round out the broader industry updates, we also have an interesting cultural moment to examine. Dr. Dre recently spoke to the New York Times about the integration of artificial intelligence in music production.
Oh, I read about this.
He stated that he actively uses it as a tool for creativity in his own workflow. His perspective is quite blunt. He argued that the only people who see this technology as a threat are those who already struggle to create.
Wow, that is a strong statement.
It highlights a growing trend where top-tier creatives are adopting these systems as collaborative instruments to enhance their vision, rather than viewing them as existential replacements.
It is always fascinating to see how the people actually doing the work view the technology versus the broader public narrative. But transitioning from multi-billion-dollar foundational models in music production, we need to look at the practical layer.
Let's talk about the tools.
Let's run through the trending tools that are actively changing how work gets done today. Instead of just listing them, let's look at the actual friction points in a standard workday and how these 6 powerful tools solve them.
I love this approach.
First up is the friction of software development, specifically the endless context switching.
Oh, jumping between windows all day.
Terrible for focus. The solution here is Slack code. This brings agentic software building directly into Slack channels. A practical use case here is a development team seamlessly co-writing and debugging a new feature alongside an artificial intelligence agent right inside their shared communication channel.
So nobody has to leave the chat.
Nobody has to switch windows, jump into a different code editor, or leave the conversation. The AI agent acts like another developer sitting in the room.
That's incredibly streamlined.
Next is the friction of heavy data extraction. For that, we have Grok Bot. This is xAI's always-on agent team that comes with its own dedicated cloud computer.
Dedicated cloud compute.
Full cloud setup just for the agent. The use case here is heavy delegation. Imagine you have a massive web scraping and data sorting task that would take a human 3 days to click through. You can delegate that entire operation to Grok Bot before you log off for the day.
Just hand it over.
You let its cloud computer grind through the brute force work overnight, and a finished sorted data set is waiting in your inbox when you get your coffee in the morning.
So basically, you can delegate your entire Friday workload on Thursday night and spend Friday morning taking the credit.
That is the dream. Third on the list addresses the friction of high-stakes accuracy. This is Precision Mode by Databricks.
I've seen the benchmarks for this.
It is a document extraction tool that is currently beating GPT 5.6 Sol in benchmarks. This is critical for zero hallucination environments like the legal field.
Because in law, you can't have an AI making things up.
Exactly. I mean, you just can't afford a hallucination. The mechanism here is that it acts as an extraction engine rather than a generative guessing engine. A paralegal could use Precision Mode to pull exact, verbatim liability clauses from hundreds of dense, 100-page vendor contracts, knowing the extraction will be completely accurate without any fabricated text.
That saves hundreds of hours of reading.
Fourth is the friction of bureaucratic reporting. We have Taku. This platform allows you to assemble, run, and share customizable artificial intelligence workflows visually.
Like building blocks.
Like visual blocks. A great use case would be automating the generation and formatting of a daily departmental sales report. You set it up once, and Taku pulls the raw data from your database, structures the narrative summary, formats the output into a clean document, and emails it to the executive team automatically every single day.
Just set it and forget it.
Fifth is the friction of consuming dense, inaccessible knowledge. The tool is CastReader, which can read absolutely anything aloud in 9 different languages with natural inflection.
9 languages.
9 languages. A practical application is taking a highly technical foreign research paper, perhaps one originally written in Mandarin about a new material science discovery, dropping it into the tool, and listening to a perfectly translated audio version during your morning commute.
That breaks down huge language barriers for researchers.
Finally, we have the marketing bottleneck, solved by Maxfusion. This is designed to generate professional video ads at scale. A marketing team could use Maxfusion to instantly spin up 50 different regional and demographic variations of a single video campaign.
50 variations instantly.
It can adjust the visuals, the background scenery, and the messaging for each specific audience in minutes rather than spending weeks in post-production.
If you really want to maximize your leverage with these systems, the secret is stacking the tools together to create entirely new capabilities.
Oh, combining them.
Yes. For instance, you could build a custom workflow in Taku designed to scrape and assemble all the latest industry news from your specific niche every morning. Then you pipe that compiled text directly into CastReader.
I see where this is going.
By connecting those two, you have effectively created a highly personalized, multilingual audio briefing that reads your custom news to you while you get ready for the day.
That is a brilliant way to use both. The sheer velocity of the developments we discussed today is incredible to process. We are watching computation literally solve month-long biological processes in a matter of weeks, and we are seeing billion-dollar infrastructure deals being made to support open-weight models that can flawlessly parse legal frameworks.
It's moving so fast.
It leaves us with a compelling question to consider. If we have reached a point where artificial intelligence can condense 18 months of biological discovery into just 6 weeks and can completely rewrite massive corporate code bases overnight, which traditionally slow and heavily bureaucratic industry is next to face this kind of hyper-accelerated timeline.
That is something to think about.
We encourage you to follow and share the deep dive with anyone trying to keep up with the relentless pace of this industry. Thank you for joining us, and we will see you in the next episode.
Thank you for listening. Goodbye.